Hi everyone, welcome to today's session. For today, our topic is packet flow. We will be learning how a packet travels within a network. Further, we will also try to understand what is the role and function of each layer within a network. So let's begin our session. Alright, so let's review how a network looks like and what is the working of a network, or I would say how a packet flow within a network when there is a request. It can be DNS request or it can be a TCP request. So let's see. So I'm going to take a reference here. So this is a diagram which I have created using this general tools from here, which took me a lot of time though. But for the simpler version and to give a reference, we will be using the OSI reference model as a reference model and trying to understand how each layer of it works within a network. So on the client, so there are 7 layers of OSI reference model. Starting from the top is application, presentation, session, transport, network, and data link layer, and then is the physical layer. So there is no start of this OSI reference model. What I mean by that is, if you're reviewing it from the client side, the first layer is layer 7. If we are reviewing it from the server side, the first layer is physical layer. You will better understand it in a while when we are going to actually see what is the functionality of each layer and what packets are getting added on each layer. So in my example, I am going to start from the client side so that from the client side, you will get a better idea how things are happening at the back end when you are trying to access something on your laptop, computer, or any other internet connected device, even on your mobile phone or any other IoT device, how the client side is forwarding the packet to the server side. So we are going from layer 7 to layer 1. So let's start. So I have just taken this out, application layer starting from the first. So, and this is a local area network. So in the LAN, we have 3 devices and there is DHCP, DNS, the end router, which is going to give us the connectivity to the internet, and the modem, which is a combination. So by default, the ISPs nowadays are providing us, it's more of an analogy gateway, which is a combination of modem and router. So once the traffic reaches the end router, it is going to get NATed using a public IP, which is the work of modem, and it is going to forward it further to the internet, where it is going to move hop by hop. So starting from the application layer, as soon as any request is being generated from the client device, let's take example of 192.168.1.4 is trying to access youtube.com. When youtube.com is getting accessed for the very first time on the browser, the first task for that machine is to resolve the DNS, to get the IP address of youtube.com, because without the IP address we cannot communicate in a network. For DNS, I would recommend to watch my other DNS in detail videos in order to better understand how actually the DNS is going to work, starting from the recursive resolver, top level, root level, and the authoritative name server, how all of these are in order and how it works. Do check the DNS detailed video. So now here, once the youtube.com is accessed on the browser, it is going to search for the DNS. Even before that, how this device 192.168.1.4 actually exists on the network? That is because once this device was plugged in and it was enabled, it got connected to a particular Wi-Fi or using an Ethernet cable connected to an internet connection. At that time, this device was given 4 things. What are those 4 things? First is the preferred IP address. Along with the preferred IP address, a subnet was assigned. Within that, this private IP falls in. Second was the DNS server. Where is the DNS server? Then there was a DHCP, which has assigned this IP address dynamically. And then is the gateway, which is the router's IP. So once these 4 things are given to a device, that device is on the network now and ready to access things on the internet. Further, youtube.com needs to be resolved. In order to access it, we need to first check the DNS resolution and get the IP address. We're going to first of all search under the host configuration file. So under host configuration file, there are some hard-coded DNS entries. If youtube.com entry doesn't exist there, it is going to reach out to operating system stub resolver in order to search for any cache. If it is not present there as well, it will reach out to recursive resolver, which is the DNS here. So the first packet leaving this machine will be of DNS. How that will look on the network layers, let's see. On the application layer, first of all, the protocol decided will be DNS here. On the presentation layer, it is going to do some encryption and encoding part. On the session layer, some session IDs will be generated, cookies will be assigned in order to keep that session intact. On the transport layer now, the protocol is going to get decided. Which transport layer protocol DNS uses. So by default here, the protocol is going to be UDP. And the port number. So the protocol is UDP and the port number for DNS is 53. So on the transport layer now UDP along with 53 port is decided. Next is network layer. On the network layer is IP addresses. So first of all, the source IP address here is going to be this 192.168.1.4 and the destination IP. So destination IP is going to be of DNS server here. And as I mentioned initially, once this device was on the network, it was given these four things information. So the device is already aware of the IP address of DNS, which is present within the network. So the destination IP address is going to be of this DNS server. Then we move on to the data link layer. There we need information about the source MAC and the destination MAC address. Source MAC address is going to be the of the device itself, and MAC address is hard coded. It is present on a NIC. So network interface card is going to pick the source MAC address for this device. But here comes the challenge now. We are not aware of the destination MAC address. We are not aware what the destination MAC address should be. And here kicks in the ARP protocol, address resolution protocol. So there is a ARP table which will be created on the device here. On the ARP table, first of all, the device is going to look for IP address to MAC address mapping, whether the destination IP address MAC address is already present on the ARP table or not. If not, then it is going to send a broadcast request to all the devices present in the network searching for the destination IP MAC address, and whichever machine matches that destination IP is going to respond back with their MAC address information. So the information will reach out to DNS. DNS will update this DNS device is going to update its own ARP table, keeping the information of this source MAC address from where the request have reached till DNS and respond back with the MAC address of its own. Now this device is aware of the MAC address, and the data link layer is going to get filled with the destination MAC address. Then the physical layer is going to change the information to the bits, and that way it is going to travel through a medium. It can be wireless, it can be wired, and it will reach the DNS. And DNS is going to again prepare the same packet back along with the DNS header, which will comprise of the information, the A record of youtube.com, and A record is going to be the IPv4 address. Once the IPv4 address is available here, then again a packet is going to get created. This time application layer is going to use another protocol, which is HTTP or HTTPS, and presentation layer, session layer again are going to do their own work. Encryption, creating a session, cookies are going to get passed. Then the transport layer, this time transport layer is going to use the TCP, which is more reliable protocol, in order to create a HTTP or HTTPS connection. Along with that, it's going to pass on the information of port number. It depends on which protocol for application layer was being used. If it is HTTP, the port number is going to be 80. If HTTPS, then port number is going to be 443. In the next layer, under the network layer, we will see the source IP as the client device, which is the private IP range, but the destination IP here is the actual youtube.com public IP, which is 77.65. So this is going to be present in this packet. Then on the data link layer, again, the source MAC address is going to be of the client's machine from the NIC, but destination MAC, again, the device is not sure where to send this packet. First of all, this information the device is going to search for is whether the destination MAC address of this youtube.com is present within the network or it's outside of the network. So for that, there is a AND logic which is going to run between the destination IP address and the subnet of this client machine. If doing the AND between the destination IP address and the subnet of the source IP address, if the IP obtained is belonging within the subnet of this local area network, the device will get aware that yes, the destination MAC address belongs to within the network, and at that time it is going to broadcast the request and again find the MAC address of the destination machine in the similar manner which we learned for the DNS. But if that AND logic returns an IP address which is outside this local area network subnet, it is now the device is aware that the actual destination belongs outside the LAN. So at that time, this device is going to forward the packet to the gateway IP address. So network layer is going to have the source IP as this device, destination IP as the youtube.com, which is a public IP. Data link layer is going to give the source MAC of this device, and the destination MAC address is going to be of a router. And it is also going to get obtained in the similar manner using the ARP protocol. Further, the physical layer is going to transfer this information in the form of bits and bytes to the gateway. Once the information will reach this gateway, then it is going to get further to the youtube.com server. And how that is going to actually happen is there is a modem which is going to get the public IP address from the Airtel. Like in our example, we are taking the ISP as Airtel. So this ISP is going to get the public IP address, and the gateway from the private IP address is going to NAT. And this public IP address will be used in order to communicate on the network. Once the NAT happens, there will be a new entire packet which will be generated. The application layer will remain unchanged, same HTTPS, presentation session layer remains same, transport layer, TCP and port is 443 remains same. From network layer onward, there are going to be some changes, like network layer source IP address is now going to get changed for in this public IP address, the aggressing IP address, and the destination IP address is still of the youtube.com. The data link layer now is the main part on which we are going to focus in order to travel within the internet, which is hop by hop. So in data link layer, the source MAC address first of all is going to be of this modem, and then the destination MAC address. So this destination MAC address is away far from it, this modem. So it is going to first discover the nearest hop where that packet can be forwarded. So it will discover using the ARP on the internet the nearest hop which will take us to the youtube.com, and for example it has a MAC address of GTHB. So first in the data link layer, the MAC address is going to be source is XABC and the destination is going to be GTHB. And physical layer is going to actually transmit it to this hop, and later on in a similar manner it is going to discover another hop. The packet will be forwarded here, and then to the next one, and then to this one. And in my example I have just kept this random, but in actual these are never going to get same. This will be different. Now once the information reaches youtube.com, here the decapsulation will happen. All this time we were discussing here how the encapsulation of packet was being done. Once the packet reaches youtube.com, it will start decapsulating, and here the actual headers, all the layer headers will be removed, and the payload, the actual data which was transmitted, YouTube server will learn that information and respond accordingly. And it can be using the same path, or it can be using a different path as well, whichever best works at that time. So that was all about the network flow, what I wanted to discuss. I hope this explains you a better, I will say detailed layer level header information, how a packet looks like when it is traveling within a network. Thank you so much everyone for watching the session. I hope you all enjoyed this. Do subscribe our channel for continuous updates on our upcoming video. If you like the video, don't forget to hit the like button, and if you want to share your valuable feedback, please share it in the comment section. It really helps us to improve. Till then, take care and keep learning.